Hello, and welcome to this video on IBM Data Virtualization Manager for zOS. Today, we are going to show you how to create a RESTful API to mainframe data using the IBM Data Virtualization Manager and zOS Connect. As many of you are aware, IBM zOS Connect provides a secure framework for creating mainframe APIs primarily focused on applications. This video shows you how to leverage the power of data virtualization to create APIs that leverage the full power of your enterprise data, mainframe and non-mainframe. Together, the IBM Data Virtualization Manager and zOS Connect provide an efficient, scalable, and secure method for unlocking mainframe applications and data for the API economy. If you're coming to this video first, then you will want to properly set up the Data Virtualization Manager and zOS Connect. There are videos on this channel that step you through the three-step process: installing the service provider, creating your DVM server instance, and creating your WOLA connection. Watching these videos and following the steps are necessary to ensure you can successfully create an API using the Data Virtualization Manager. So let's get started. The first thing you're going to want to do is to create a virtual table over your data source. I'm going to expand the virtual table directory, and you can see that I have many virtual tables that have been built over various backend data sources from vSAN, DB2, IMS, IDMS, Oracle, etc. One in particular we'll look at this point is called Staff VS, and it is a virtual table that I've built over a vSAM file. And if you were to edit it, you can see that it's typed vSAM, and that's the name of the file that it's pointed towards. Once these virtual tables are created, you can then right-click and generate query to get the data from those virtual tables. It just ran that SQL and returns this result set. These virtual tables are easy to create. For example, if I wanted to create another virtual table, I could right-click and say Create Virtual Table, type vSAM, name the table, point to the copybook for the table, then name the vSAM file and validate it. It's now validated and it's typed KSDS, and finish. Now that virtual table is out here and available for use too. Another way to create virtual tables over vSAM or sequential files is to leverage the use of Application Data Discovery, or ADDI. If you use ADDI in your shop, we'll have the data sets listed as I do here, and then you could just point and click to create your virtual tables. I'll do that for 3 of them. And it comes up and tells you the 3 tables that it's found and the names that it's about to create the virtual tables under. You can validate those. You can see that 2 of them are physical sequential and 1 is vSAM. And when you click Finish, it's going to actually create those 3 virtual tables for those data sources. There we go. Now they're all 3 out here for use, and you can query upon those as well. There we go. Once you have the virtual table created, you can then create a RESTful service to access that virtual table. So let's do that now. Under the services directory and under web services, I've created a directory called data, and I've created web services out here for various different virtual tables. One of which is called staff. And if I look at that RESTful service, it has many operations in it, from getting all records off the table, get by job, get by name, get by years, an insert, update, and delete. And if you were to look at these operations that have been created, you can see the SQL statement that's out here. For example, I'm looking at the get all that is selecting all columns from staff VS, which is the virtual table that we created up top. You can then execute these web services RESTfully by right-clicking and choosing Execute Query. It pulls up the RESTful command that it's about to execute on the host that it's running on, RS-28, and the port 14081, which is the port that zOS Connect is listening on. And when you say yes, it executes it on your default browser, goes out, runs the query, and returns the data in JSON format. These services are very easy to create. If we wanted to create another one at this point that would say be a get by department, I can show you how to do that. We would click Create Operation, and it's a REST operation. We would point it towards the data source, the virtual table. We would name the operation, and then we would change the SQL accordingly. Question mark is the parameter marker that we're going to supply as input, which is going to be the department number we're searching for. When I say next, it knows it has one input field that I'm going to label department. The result set will keep the same, returning all the columns. And when I say finish, it's going to create that RESTful service out here, get department. There it is. Now I could right click and execute this service. And I change the department name to a department that I know is out there. And when I execute it, it comes back and returns only the entries that had department 20. I also have other services out here that have this staff table on it that are not on vSAM, but for example, here on DB2. And if you look at the operation and the SQL within the operation, you can see that he's going to get the columns from DSN1 Q staff, which is another virtual table that if we go back to the virtual table list, here it is, we can see it. We could query on it as well, but if you edit it, you'll see that he's a DBMS source. He's DB2, and there's the target system DSN1, the table schema Q, and the table is staff. And when you execute this query RESTfully, it will run and return all the information from the DB2 staff table. There we go. You can see the DB2 staff table, in addition to the name, ID, department, and job, also has salary and years, whereas the vSAM staff table did not have that. I also have the staff table that's out here on Oracle, and if you run that RESTful service, he will go out to the Oracle table and return all the staff information from the Oracle table. There it is. And the Oracle table also has staff and years, just like the DB2 table did. And then where it gets kind of exciting is you can create a service that joins all those back-end data sources together in one service. For example, I have one here that's already been built that's joining that vSAM staff table and that Oracle staff table and that DB2 staff table. And if you were to look at this service, you'll see the SQL statement is getting the key ID, the name, the department, the job, and the years from vSAM, but it's getting the salary off the Oracle table, and it's getting the commission off the DB2 table. And they're joined together on ID. And if you were to execute this RESTful service, it runs and goes out to vSAM, Oracle, and DB2 and returns the data. Here's the salary from Oracle, the department, job, years, and ID from vSAM, and the name from vSAM, as well as the commission from DB2. Now, once you have these services created in the Data Virtualization Manager, you can easily generate and export the SAR files and then import those into the Data Studio and create APIs. Let's do that now. So if I wanted to export the SAR files for all of these services, I could right-click on Staff and say, Generate SAR file. It now, if I look at the console, it generated the SAR files for all of those. I could then now go over to the Data Studio and create a project and import those SAR files to build the API. So let's do that. I'm going to create a new zOS Connect API project. I'm going to call it vsam.staff. There, it's created. First thing I'm going to do is right-click on it and import those SAR, all of those SAR files that we've generated from the Data Virtualization Manager. There they are. Okay. Now we don't have to create all those operations over here, but we'll create a couple or a few of them. The first one, let's create the get all. So I'll define the path. I know it's a get, so I don't need the post or the put or the delete. The service I'm going to choose is the get all service. And we'll create another one. Let's create the get department. And I'll question mark DEPT and define department as input into this service. Remove the post, put, and delete. For the service, I'm going to choose the get department service. And for the mapping, I'm going to map department to department, save it, and we can create one more. Let's create the three-level join between vSAM, Oracle, and DB2. And I'll call that get vSAM, Oracle, DB2. There's no input. I'll remove the post, the put, and the delete. Point the service towards the left join between vSAM, Oracle, and DB2. Now that we have all these paths created, we can deploy those APIs to the zOS Connect server that I've connected to. So I'm going to right-click and deploy. Say OK. And it's now deployed those all to the zOS Connect server. You can see it out here, vSAM staff. And if you right-click, you can open and execute those APIs in the Swagger UI. There's the list of operations. There's the get all. If I plug my password in and run it, you can see that just like within the Data Virtualization Manager server, the API ran and went out and got all the information off the vSAM file. We can also run the get by department, plugging in the department number. There it is, and return those only with the 20 department. And we can do the join between vSAM, Oracle, and DB2. There it is. It's just that simple. You should now be able to create a RESTful API to mainframe data using the IBM Data Virtualization Manager for zOS and IBM zOS Connect. Thank you for watching and check out other videos on this channel.